In this video, we are going to answer some questions about an equation that is in standard form. So I'll read the situation and then the questions and we'll jump in. So the number of slugs in Kelly's garden in thousands as a factor of x inches of rainfall is modeled by the following equation. So S of x is equal to negative x squared plus 6x. So again, x is the number, or the inches of rainfall. Inches of rainfall. And our dependent variable, s, or the output of our function, is the number of slugs in thousands. Number of slugs in thousands. Now, what's the maximum number of slugs possible? And how many centimeters? Ooh, I have inches of rain here, centimeters of rain here. Okay, let's change this. This should be inches. How many inches of rain would correspond with no slugs at all? So we have two things that we're trying to figure out here. The first is the maximum number of slugs possible. Maximum number of slugs possible. And the other thing that we're trying to figure out is how many inches of rain would correspond with no slugs at all. And so these are both going to be different. These are going to be represented by different parts of our parabola once we graph it. The maximum number of slugs possible, you might have guessed, that that's going to be represented by the vertex, or the highest point of our parabola. And here, the point at which there are no slugs at all, that would just be where this value, our y-coordinate, is 0. So that is going to be our x-intercepts. Our x-intercepts. And that's where we're going to start. We're going to start with finding the x-intercepts of this equation. So again, the equation is S of x is equal to negative x squared plus 6x. So I'm going to write that over here. We have S of x. Let's see, actually, let me label this like this. We're going to find our x-intercepts. Our x-intercepts. And we know that S of x is equal to negative x squared plus 6x. Now, when we want to find our x-intercepts, there's a few ways that we can do it. We can do it by factoring. We could also use the quadratic formula. I'm just going to do it by factoring here. And so I'm going to factor negative x squared plus 6x. And so on the left-hand side, it's going to be the same, s of x. And then here, I have an x factor in both of these terms. And so I'm going to pull out an x from both of these terms. So this is going to become x times negative x plus 6. And we could verify that, that this was factored correctly by distributing this x back over the contents of this second set of parentheses here. That would give us negative x squared plus 6 times x. All right, the next thing that I'm going to do, I'm going to rewrite this equation. And let's see, I'm going to keep this x factor in front, and I'm going to rearrange these. So I'm going to put the 6 in front and the negative x second, so that it looks like that. And that's just for my own understanding and clarity. I think it looks a little bit better like that. The next thing that we're going to do is we're going to just look at this and imagine what values of x are going to make this left-hand side of the equation 0. Well, if I substituted in a 0 for x, then I would have 0 times 6 subtract x, and that would be 0 on the right-hand side, 0 on the left-hand side. So that would, the output of that, I should say, would be 0. And so we know that we have one x-intercept at x is equal to 0, and remember y is going to be equal to 0 at our x-intercept, and so we have one x-intercept at 0, 0, and that's just because if I substituted in a 0 for this x, then it would multiply this to 0, and my output would be 0. And I should say x-intercepts at 0, 0, and then for this set of parentheses here, I can tell that if I substitute in a 6 for x, then I will have 6 subtract 6, which is 0. And so this set of parentheses will be equal to 0. 0 times anything is going to be equal to 0, and so my output will be 0. So I have another x-intercept at 6, comma 0. So again, I have two x-intercepts, one where x is equal to 0, one where x is equal to 6, and at both of those points, my y-coordinate, this second number here, this y-coordinate will be equal to 0 because it'll be right on the x-axis. So I know my x-intercepts, and once I know my x-intercepts, I can put them on my graph. And so we have one at x is equal to 0 right here, and then another one at x is equal to 6 right here. Once I have two x-intercepts on a graph, I always want to put the axis of symmetry on the graph also. And so the axis of symmetry, remember, is just going to be halfway in between my two x-intercepts. So if I have one at 0 and one at 6, halfway between 0 and 6 is 3. And so my axis of symmetry is going to be at x is equal to 3. So it's going to be, actually, let me do this in yellow. It's going to be at x is equal to 3. So this will be my axis of symmetry. This will be the line whereby the parabola will be a mirror image on either side of this line. And that's just because it's halfway between my two x-intercepts. All right, so if I know that the x-intercepts of my parabola are 0, 0, and 6, 0, in other words, where x is equal to 0 and where x is equal to 6, those are the points where I will have no slugs at all, because that's where the parabola is going to cross the x-axis at these points, which is going to indicate that I'm going to have no slugs where there's no rainfall at all, 0 centimeters, and no, I said 0 centimeters, 0 inches of rainfall, 0 inches of rainfall. Let's try this one more time. 0 inches of rainfall, and then also I'm going to have no slugs where there's 6 inches of rainfall. These are my two x-intercepts. They correspond with having no slugs, and that'll be a little bit more clear once we actually put the parabola on here. The next thing that we want to find for this maximum number of slugs is we want to find the vertex. We want to find the vertex. And so to find the vertex, we know that our vertex is going to be on our axis of symmetry. So it's going to be on this yellow line here. And so we know that the x value for our vertex is going to be 3. So for our vertex, we already know that x is equal to 3. If we know that x is equal to 3, then we can substitute 3 into our equation and find out what we get as the output from our equation. We can find out what s of x is equal to, or what you might be more familiar with thinking of what y is equal to. Remember, s of x over here is the same thing as y. We're just using function notation here. Okay, so if I know that x is equal to 3, what is the left-hand side going to be equal to? Well, let's substitute in and find out. So we have s of 3. Remember, I just replaced x with 3. S of 3 is equal to negative 3 squared plus 6 times 3. And again, I just replaced my x's with 3's, and I can simplify what I have on the right-hand side here. So 3 squared is 9, and we have the negative sign up front, so we have negative 9. And we're adding to that 6 times 3. So 6 times 3 is 18. And so negative 9 plus 18, it's like we're starting at negative 9 on the number line, and then we're moving to the right 18, and we're becoming 18 more positive, and so that's going to give me 9. So again, s of 3 is equal to 9. So when my x value is 3, my y value is 9, and I can write that like this. 3, 9. This is the vertex of my parabola. So again, the x value is 3, and now we know that the y value is 9. So let's go ahead and plot that here. So that's going to be right where y is equal to 9. So it's right there. And we already know our y-intercept because it goes right through the origin here. And so we have all the information that we need to graph this parabola, which is what we're going to do. So let's see how nicely I can make this curve here. Oh, pretty good. Pretty good. Again, it's just a hand-drawn approximation. There we go, like that. And note that this parabola, if we were graphing it perfectly, it would be symmetric on either side of this axis of symmetry. It's a little bit hard to draw perfectly symmetrically, at least for me, and so that's why it doesn't look perfectly symmetric. We have answered both of these questions. So for this question on the right, how many inches of rain correspond with no slugs at all? Well, 0 inches of rain. Let me write this in the right color here. I'll write it down here with a little arrow. That was a bad arrow. Let's continue this here. 0 inches. 0 inches of rain. And 6 inches of rain. That's the number of inches that would correspond with no slugs at all. And then the maximum number of slugs possible, that's our vertex. That's our vertex that we found. And that was at 3 inches of rain. And then our maximum number of slugs, well, the maximum number was the y value of our vertex, which is right here, right at 9. And remember, we're measuring our slugs in thousands here, so it's really 9,000 slugs. So the maximum number, I'll just indicate with an arrow here, that's at 9,000 slugs. That's the maximum number of slugs that we could expect. So as the rainfall increases, we get more and more slugs, and then there's a certain point where the number of slugs starts to decline. I don't know, maybe the mating conditions or the egg conditions or something isn't quite right anymore, and so the number of slugs declines. And then just to illustrate this, hopefully a little more clearly, this point right here corresponds with the maximum number of slugs, And then these points down here, the origin one, and then this point right here, those correspond, ooh, that's a bad arrow. There we go. Those points correspond with no slugs. No slugs at 0 inches of rain and 6 inches of rain. So we found out the maximum number of slugs possible. We found out how many inches of rain would correspond with no slugs at all. We have answered both of these questions, and we are done.